When things are changing fast, the past cannot be a guide to the future. With these inspiring thoughts, in this presentation, I am going to discuss some statistical models to study non-stationarity in hydrology. My name is Arpita Mondal. I work in the Department of Civil Engineering and the Interdisciplinary Program in Climate Studies at IIT Bombay. The topic of non-stationarity has garnered quite a bit of attention in hydrologic literature. We see contradicting views on whether stationarity is dead or stationarity should be continued as an assumption for hydrologic designs. In this study, we are going to consider non-stationarity in four main characteristics of hydrologic extremes: intensity, duration, frequency, and seasonality or timing of extremes. We consider a sufficiently high threshold and values in the hydrologic time series which go above the threshold are considered as extremes. An extreme spell consists of the values which are consecutive and consistently above the threshold. The duration for which the values lie above the threshold is modeled using a geometric distribution, which is a discrete probability distribution with a single parameter theta. The intensity represents the largest magnitude within each spell, and that is modeled by the generalized Pareto distribution with two parameters, scale and shape. The number of spells denote the frequency of extremes, and that is modeled by the Poisson distribution with a single rate parameter lambda. And finally, the seasonality of peak flows or flood peak seasonality uses circular statistics to understand the probability distribution around the observation of dates in each water year when annual maximum flood occurs. So to model the seasonality, we use the von Mises distribution in a circular statistics framework that has two parameters, location and scale. Under non-stationarity, each of these parameters is modeled as a function of predictors x1 to xk. So while in the stationary distribution, we have corresponding to a given quantile a particular probability of exceedance, corresponding to a given quantile on the other hand for non-stationary distribution, the, the probability of exceedance changes. So from P0, it becomes P1, P2 and so on. We use the method of maximum likelihood or Bayesian techniques for estimation of these parameters, and then we use criteria such as the AIC or the BIC to choose the best model. Our results show that extreme rainfall characteristics such as intensity and frequency in India exhibit significant non-stationarity, and that is mainly due to local temperature changes as opposed to global changes such as global warming or ENSO. On the other hand, the timing of floods in northwest United States is found to be more driven by soil moisture as compared to precipitation or snow melt. To summarize, these statistical models offer a useful set of tools to study non-stationarity in hydrologic extremes, and our results reveal significant non-stationarity in characteristics of these hydrologic extremes, both in India as well as other parts of the world. And these non-stationarities need to be considered for hydrologic designs for the future. Thank you for listening.